If your Excel times are off by 1 hour or even a full day, you're not crazy, and your data probably isn't wrong either. Most time zone mistakes come from one simple problem. Excel stores a date time as a number, but it does not store the time zone. So when you paste timestamps from logs, APIs, or databases, Excel quietly guesses what you meant. That guess breaks the moment UTC meets local time, or when daylight saving time changes. In this video, you'll build a reliable mental model for fixing those errors. We'll separate 3 things that often get mixed up: the timestamp value, the time zone context, and the rules like DST that change over time. Then we'll walk through practical formulas and workflows that hold up in real files. The goal is simple. You should be able to look at any timestamp in Excel and answer, what time is this, where, and according to which rules. Next step. Let's start with the core concept. In Excel, a date time is a serial number. The integer part is the day count. The decimal part is the fraction of a day. So 0.5 means noon. That's it. There is no field for UTC, Berlin, or New York. So a value like 2026-04-15-1200 is just 12 o'clock, with no location attached. The time zone only exists in your head or in the text label that came with the data. That's why 2 people can open the same file and interpret it differently, especially if the timestamps were originally text. It also explains why formatting doesn't fix anything. Changing the cell format changes how the number is displayed, not what it means. Once you accept that Excel is time zone blind, you stop chasing random 1-hour fixes and you start building explicit conversions. And that's the theme for everything else. Make the time zone an explicit part of your spreadsheet logic. Next step. Next, you need a clean distinction between UTC and local time. UTC is a global reference clock. It does not change for daylight saving time. Local time is what people read on a wall clock, and it can shift during the year. The conversion between them is an offset, like -5 hours or +1 hour. But that offset is not constant in many places because DST changes it. Here's the practical mistake. People treat the offset like a fixed number and apply it to every row. That works for a small date range, then silently fails around DST boundaries. Another common issue is mixing local time that was recorded as if it were UTC. That creates a consistent shift, often exactly your local offset. So the first question you should ask about any dataset is, were these timestamps generated in UTC or generated in local time? If you don't know, you can often detect it by comparing a known event time with what Excel shows. Next step. Now let's talk about imports, because that's where most errors start. Excel can ingest timestamps as true date time values or as text. If it comes in as text, Excel may parse it using your system locale, your regional settings, and sometimes even your default time zone assumptions in connected tools. ISO 8601 strings are the most common, like 2026-04-15, T12:34:56Z. The Z means UTC. If you drop the Z, you've lost the only reliable clue. Another pattern is an explicit offset, like +02:00. That offset is part of the timestamp, and it matters. If you strip it during cleanup, you're changing the meaning. So the safe workflow is, keep the original raw timestamp column untouched, store it as text, and create a second column where you parse and convert. That way, if Excel misparses something, you can always trace it back. Think of it like keeping raw data in a transformed view. Next step. Before you convert anything, do a quick diagnosis. You're looking for 3 signatures. Signature 1 is a constant offset. Everything is exactly plus or minus the same hours. That usually means UTC was treated as local, or local was treated as UTC. Signature 2 is a 1-hour flip that happens on specific dates. That's classic daylight saving time. Signature 3 is a date shift, where times near midnight jump to the previous or next day. That often happens when you apply an offset without considering that Excel stores days as whole numbers. A simple test is to pick a row you can verify, like a system event you know the real time for, and calculate the difference between your Excel value and the expected value. If the difference is stable, you likely need a fixed offset. If it changes around spring or autumn, you need DST-aware logic. Doing this diagnosis first saves you from fixing the wrong problem and making the dataset less trustworthy. Next step. Let's handle the easiest case first, fixed offset conversion. This is appropriate when you know the offset is constant for your entire dataset, like converting UTC to a region that does not observe DST, or when your date range avoids DST changes. The math is simple. 1 hour is 1 divided by 24 in Excel, so adding 2 hours is adding 2 over 24. If you have a UTC date time in A2, and you want local time that is UTC plus 2, you add 2 over 24. If you want UTC minus 5, you subtract 5 over 24. The key is to store the offset in a cell, not hard-coded in the formula. That makes audits and updates easy. Also, keep the result as a true date-time serial, not as text. That way you can sort, group, and chart correctly. Fixed offsets are not bad. They're just limited. The moment DST enters the picture, you need a different approach. Next step. Daylight saving time is where spreadsheets usually fall apart, because the offset depends on the date. Excel does not have a built-in universal convert UTC to time zone function that knows historical DST rules for every region, so you need a strategy. The most reliable spreadsheet strategy is to use a lookup table of DST periods and offsets for the specific region you care about. That sounds heavy, but it's manageable. You create a table with start date time in UTC, end date time in UTC, and the offset to apply during that interval. Then, for each timestamp, you find which interval it falls into and apply that offset. This approach is auditable, and it works for historical data because you control the rules. The trade-off is maintenance. If your region changes DST rules, you update the table. For many business datasets, that's acceptable and safer than guessing. The key is to treat DST as data, not as a magical Excel setting. Next step. Here's how the DST lookup works in plain terms. You have a table with 3 columns: UTC start, UTC end, and offset hours. For example, one row might say from 2026-03-29-01:00 UTC to 2026-10-25-01:00 UTC. Offset is +2. Outside that range, offset is +1. Then, for a UTC timestamp, you look up the matching row where UTC start is less than or equal to the timestamp, and UTC end is greater than the timestamp. Once you have offset hours, you convert with timestamp plus offset hours divided by 24. In modern Excel, you can do this cleanly with a lookup that returns the correct offset based on the latest UTC start, not after your timestamp, and then you also ensure you're not past UTC end. If that sounds complex, keep it simple. Start with 2 seasons, standard and summer, and expand only if you need multiple years and rule changes. The big win is that your conversion becomes consistent and explainable. Next step. Now let's cover a sneaky issue: ambiguous and missing local times. When clocks move forward, there is a gap. Some local times never happen. When clocks move back, there is an overlap. Some local times happen twice. If your source data is in local time without a UTC offset, you may not be able to uniquely convert it to UTC around those transitions. That's not an Excel problem, it's a data problem. The fix is to capture more information at the source, like storing UTC, or storing local time plus offset, or storing a time zone identifier. In Excel, the best you can do is flag those risky intervals. For example, you can mark timestamps that fall within the gap or overlap window based on your DST table. Then you can decide a policy. Pick the first occurrence, pick the second, or treat it as invalid and escalate. The important part is not to silently convert and pretend it's precise. Next step. Another common source of timestamp errors is Unix time, also called Epoch time. This is a single number, usually seconds or milliseconds, since 1970-01-01 in UTC. People paste it into Excel and it looks like a random big integer. Then they divide by the wrong factor, or forget that Excel's day 0 is different. The correct approach is convert the epoch to days, then add the Excel date for 1970-01-01. For seconds, you divide by 86,400. For milliseconds, you divide by 86,400 times 1,000. After that, you have a UTC date time serial. Then you apply your fixed offset or DST-aware offset like we discussed. 2 warnings. First, watch for milliseconds versus seconds. Second, be careful with rounding. If you round too early, you can lose seconds and create subtle ordering bugs in logs. Keep full precision and format for display at the end. Next step. Let's talk about validation, because conversions feel correct right up until they break a report. After you convert, run 3 checks. First, spot check a handful of rows against a trusted source, like the original system that produced the timestamps. Second, check sorting. If your converted times are true datetime values, sorting should match the original event order. If it doesn't, you may have text dates or rounding issues. Third, check the DST boundary days. Build a small pivot or summary that counts events per hour for those days. If you see a missing hour on spring forward, that can be correct for local time. If you see a duplicated hour on fallback, that can also be correct, but only if you understand what it means. The point is to validate behavior, not just individual cells. Once these checks pass, you can be confident your spreadsheet will hold up when someone else reuses it. Next step. To make this sustainable, set up a repeatable structure. Keep 3 columns: raw timestamp text, parsed UTC, and local time. Raw stays untouched. Parsed UTC is your best interpretation of the raw value as a UTC serial using consistent parsing rules. Local time is then derived from parsed UTC using either a fixed offset cell or your DST lookup table. Add a 4th column called time zone note, where you store something like UTC, UTC plus 2, or the region name that your DST table represents. This sounds simple, but it prevents the most common spreadsheet failure. Someone copies the local time column into another file and forgets what it represents. If you share the workbook, protect the raw column from accidental edits, and document the assumptions in one place, like all source times are UTC unless marked. When timestamps are business critical, clarity beats clever formulas every time. Next step. Let's wrap it up with the practical takeaway. Excel isn't bad at time zones, it simply doesn't track them. So your job is to carry the time zone context alongside the numbers. If your offset is truly constant, use a fixed offset in hours and keep it in a cell. If DST is involved, treat DST rules as data and use a lookup table that returns the right offset for each timestamp. If your source is local time without an offset, be extra careful around DST transitions because some conversions are genuinely ambiguous. And if you're dealing with Epoch timestamps, convert to a UTC serial first, then apply the same conversion logic. If you want, I can also provide a ready-to-paste DST table template for a specific region you work with. For now, I'm curious. Do you usually receive timestamps as UTC or as local time? Leave a comment with A for UTC or B for local. And if you want more Excel deep dives like this, subscribe. Subscribe to keep optimizing your workflow and get back more of your time.